Hi there. In this video, I want to give you a solid introduction to the Pythagorean theorem. So let's get right into it. So what is the Pythagorean theorem? So whenever we have a right triangle, and it is very important that this be a right triangle, that has lengths a, b, and c. The Pythagorean theorem says that a squared plus b squared is equal to c squared. Now, one thing you have to pay attention to is the c. C is very important because c has to be the length opposite to the right angle. In other words, it has to be the hypotenuse of the triangle, which is the longest side of this right triangle. A and b you can interchange as you like. So to clear some of your doubts up, here is an example question. So let's say you have a right triangle with side length 5, 13, and say some value x. Let's say you want to solve for x here. Now you can do that using the Pythagorean theorem. So firstly, you have to identify what a, b, and c are. So remember, the most important thing is that c has to be the length opposite the right angle, sorry. So in this case, c will be 13, right? So you've got to note that down first, that c is equal to 13. Now, a and b, like I said, you can interchange as you like. So in this case, let's just let a be equal to 5, and we will let b be equal to x. All right? So now, let's punch in these numbers into the Pythagorean theorem. So we know that a squared plus b squared is equal to c squared. So what is a in this case? A is 5. What is b in this case? B is x, and I will put x in yellow because that's what we're trying to look for. And c in this case will be 13. All right, so now you know that 5 squared is equal to 25. X squared remains as x squared, and 13 squared is 169. All right. Now, let's subtract 25 from both sides to cancel out the 25 on the left side. So when you cancel that out on the left-hand side, you're left with x squared. And that is simply equal to 144. All right, and now finally to get x, all you have to do is square root both sides. Right? So once you square root, on the left-hand side, the square cancels out, so you are left with x. And on the right-hand side, you are left with 12. So that is the final answer. X is equal to 12 in this case. So what that means is that for this triangle, x here is equal to 12. All right? So that's one example. Now let's move on to the proof of this theorem. So let me draw you a square. Now you might be thinking, we are taking a look at right triangles, but why do I have a square here? Now let me draw a few more lines so that becomes a bit more obvious. So here we know that a square has 4 90-degree angles, so all these angles are right angles. Now what I'm going to do is that I am going to make a little mark on all the sides, right? So I am going to make a little mark on all the sides, and I will connect these lines. So that connects to that, that connects to that, that connects to that, and that connects to that. All right. Now, this diagram is drawn absolutely horribly, but you should be able to tell that this little shape in the middle here, this shape that I am highlighting in red here, that shape there is a square. And notice that these shapes here in yellow, these are all right triangles. All right, so let me just highlight that in for you. Okay, here we have a really ugly diagram, and we will complement that with some really ugly writing. So here, for one of the right triangles, we want the lengths to be a, b, and c, so I will note that down. And here we have all the same lengths for all these right triangles, right? So all of them will have lengths a, b, and c. And remember that c is always the longest side. Okay. So now, we have a giant square. right? The area of this giant square is a plus b squared. Now, why is it a plus b squared? Because one of the side lengths, so one of these side lengths here is b plus a. In other words, a plus b, it's the same thing. So we know that the area of the square is going to be a plus b squared. Now we can also express this area in a different way. So we can express this area as the area of the four right triangles plus the area of the square in the middle. So what is the area of one of the right triangles? So we know that the area of a right triangle is just half of base times height. So in this case, the base is just b and the height is a, right? And remember, we have 4 of these, so I will multiply that by 4. And don't forget that we have that square in the middle, and the square has side length c. So I will put that down, so it's equal to c squared. That's the area of the square. Okay, so now we just need to simplify this, and at the end we will end up with the Pythagorean theorem. So let me rewrite the left-hand side so that it's easier to expand. So a plus b squared is equal to a plus b times a plus b. And on the right-hand side, notice that here we can divide the 4 by 2, so you're left with 2. So what you get is you get 2ab, or 2ba, it's the same, plus c squared. And on the left-hand side, let us expand this 1 by 1. So you have to take the first term in the first bracket and multiply it by these 2 terms first. Right, so what we get is we get a times a, which is a squared, plus a times b, which is ab. And then you have to go on and with the second term in the first bracket, so you have to multiply by these 2 now. So you end up with b times a, which is again ab, and you have b times b, which is b squared. And on the right hand side, we still have 2ab plus c squared. Okay, we're getting closer. Now, notice that here we have ab plus ab, so these 2 are the same terms, so we have 2 of them. So we can have 2ab here, plus b squared, and we have an a squared in front, right? And that is equal to 2ab plus c squared. Now, notice that we have a 2ab on both sides, so let us minus 2ab from both sides. Alright, so over here, that cancels, and what are you left with? You are left with the Pythagorean theorem in all of its glory. A squared plus b squared equals c squared. So that is one of the proofs for the Pythagorean theorem. There are many more, and there's a link in the description if you want to learn more. So that's pretty much it for this video. Thanks for watching, and if you found this video helpful, don't forget to like and subscribe to my channel and write comments. I will read all of them, and I appreciate suggestions and questions in the comments. Thanks for watching.